so this is your sample space for totals. We could actually do a completely different sample space. I need you lot at the back to focus, please. If I want just what's going on the spinner and the die, I could rewrite this sample space like this. 1 on the spinner, 1 on the die, 0 on the spinner. 1 on the die, 7 on the spinner. 1 on the die, 12 on the spinner, and so forth. And so in answering the question for part B, these are the only pairs, these ones I'm about to highlight in blue, in which you have both numbers that are multiples of 3, that are in the 3 times tables. So that's 4. Still have a total of 24 different outcomes, because there's 24 pairs of numbers that could potentially be rolled and spun together. All right, what about both numbers being prime? So if we're looking for both numbers being prime, where would we be looking?
In 7.
So in the 7 column only, essentially, because that's the only prime number in the spinner. Where's the prime numbers in the die? 1's not prime.
3 and 5.
3's prime. So is 5. What else is prime? 2. So essentially you've got this pair, 2 and 7, 3 and 7, 5 and 7. So there's only 3 in which both numbers are prime. Probability that the 2 numbers are the same, what's that going to be? So prime number has only 2 factors, 1 and itself. All right, where have we got both numbers being the same? Anywhere? If I roll the die, that's got the numbers 1, 2, 3, 4, 5 and 6, and I've got the numbers 0, 7, 12 and 18 on my spinner. Am I ever going to get 2 numbers the same? Yes or no? No, because all the numbers on the spinner are different to all the numbers on the die. So that probability is going to be what? 0. All right, this time the product of the 2 numbers is 24 or greater. What does product mean? Product means? No, not sum. Product means if you, what do you do to 2 numbers if you want to find their product? No. You have to multiply them. Yeah, multiply or times. So product. So how would we find the product of the 2 numbers greater than, is 24 or greater? So let's look at these 2 numbers. Wait, there's more than that. We could redraw our sample space. So again, I've listed the numbers 1 to 6 and 0 to 12. The product means times. So this product, these are all 0. Because any number times by 0 is 0. Second column, do it. What's the product of 7 and all of those numbers? So there's our first 6 numbers of our 7 times table. Next one, you've got 12. What's the product? Yeah, 12, 24, 36, 48, 60, 72. And then the next one, what's the product? Or here's testing your skills. 18, 36. Next one, given up. 54. Just keep adding 18. Not 68, no. No. 72. Quick way of adding 18. Quick way of adding 18. Add 20. Take 2. Quick way of adding 18. Add 20. Take 2. So next one is 90 and the next one is 108. All right, how many of these? So the question we're asked is the product is 24 or more. How many of these have a product that is 24 or more? All right, product of 24 or more. I've highlighted pretty much all of the ones that are 24 or more. We do include 24 because it doesn't say greater than 24. It says 24 or more.
13.
So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Yeah, 13. So our probability is going to be 13 out of 24. All right, so that's a really quick recap of sample space where you've got 2 events occurring and we're doing a grid or an array. So we use the grid here for totals. We just did it here for multiplication. And we also did it by listing the pairs. Because dependent on the question will depend on what you need to do with your sample space. All right, the next question I want you to have a go at missing anything. So try and be systematic in your approach. So the word must, 4 cards, shuffle. 4 cards are down to form a word. It doesn't have to be a proper English word. Write down all the possible words that you can form. Go, do it. From the 4 letters, M, A, S and T. There you go, there's the first one. Proper word, it's just any 4 letters. M, A, S and T. So we're trying to find all the different orders. So M-A-S-T, M-A-T-S. Okay, they're the 2 that start with M-A. I'm now going to look at starting with M-S. Yep. Yeah, whatever it is. That's 2. The next 2 start with M and S. And the final 2 that start with M will be M followed by T.
Is that all the M words?
So, and that's it. So in terms of being systematic, for some of you, you're learning a new process. Think about all the words that start with M, and then the second letter, try and be systematic. Rather than doing just starting with M, you'll have a whole heap of random words that you might miss. Whereas if we go M and a second letter the same, then we know the other 2 just need to be swapped over. And then the system is, well, I did M-A-S-T as my first word, so then try M-S and then M-T. Now I'm done with all the words that start with M. What would be the next thing to do? Yeah, look at all the words that start with another letter. A is a good one. So if we start with A, and maybe AM. So keep going. How many are there? Alana has told us there are 24. Right, A-S-T-M, A-S-M-T, A-S, sorry, not A-S, try again. And then next letter, A-T, M-S-A-T-S-M. So you might actually notice a pattern here. There are 6 words that start with M. There are 6 words that start with A. How many do you reckon there's going to be that start with S?
The same amount.
Same number. Yep.
Oh my goodness.
Do it. S-T-M-A, S-T-A-M. You can see by being systematic we can get quite quick. S-M-A-T, S-M-T-A, S-T-A-M-S-T-M-A. There's your 6 starting with S. And then we've got 6 more starting with T. So I made a mistake here, so it shouldn't be S-T. I was doing them too quick. So S-A-T-M, S-A-M-T. And then finally, the one starting with T, we can start with T-M-A-S, T-M-S-A, T A S M T A M S T S A M T S M A. So the system there is start with one letter and then the second letter, do whatever you can with two the same, and then repeat for every letter. So 24 possible outcomes after all of that. Let's see if we can find these probabilities. So that is one strategy. You can see how that's tedious, doing that big list like that, and there's a chance of you missing something. So we're going to learn another strategy in a minute.
What? Okay, no, that's 6.
There's 6 out of
24.
24. How many have 2 vowels? Aoife, you're up.
5.
5 have 2 vowels, are we sure?
Wait, no, 2 vowels, none.
None. The only vowel in any of those words is an A.
Okay, if it says it has 2 consonants.
Oh, I thought we were talking about any word.
Why did you call it?
All right, so exactly 2. Then the answer is 0. If it's at least 2, then all of them. So 24 out of 24, or that is a certainty. Has the S first or last? Has the S first or last? So these ones all have it first. Then we've got how many have it last? So you've got 12 all up. First or last. All right, so that's using a systematic list as your sample space.